Activity 2.9, notes, a few notes to help you figure out how to set this stuff up. So remember that we're looking at the energizing question slash activity, and in the first case we have someone who is at a height of 10 meters, and we've defined the bottom to be 0 meters, and this guy's attached to a bungee cord, and remember he's going to drop off, and the length of the cord is going to be 4 meters. So we're going to start by defining the energy at the top, and so that the energy is comprised of kinetic energy, which is 1/2 mv squared, gravitational potential energy, which is mgh, elastic potential energy, which we're going to calculate, and then the energy total, which is going to be the sum of all of the energies. And the key idea here is that this does not change. Okay, so the idea here is that the kinetic energy, gravitational potential energy, and elastic potential energy are all going to add up to the total energy of the system. So we're going to start by calculating the energy. Okay, now you recall that in that picture that the height was 10 meters and that the person's mass was 100 kilograms. So GPE is going to equal mass, 100 kilograms, times G for gravity, which is 10 meters per second squared, and then the height of 10 meters, and that's going to give me 10,000 joules. The kinetic energy, 1/2 mv squared, is just equal to 0 joules, because V is equal to 0, and the elastic potential energy is equal to 0 joules, because there's no stretch. Right? The thing hasn't been, the bungee cord has not been stretched out yet, so there's no stretch. Okay, so what does our energy graph look like? Our energy bar graph look like? The kinetic energy, the gravitational potential energy, we said was 10,000 joules. There's no kinetic energy, there's no elastic potential energy, and the total energy is the same as the gravitational potential energy. So let's look at a different case. Now look, the bottom line here is I'm going to draw a similar picture, but this time the guy's going to have gone down 5 meters. So what does this mean? This means that since the cord was 4 meters, that I've actually stretched out the cord a little bit. Now, back to what we started out with. Let's look at this energy graph, or the energy bar graph. I know that my total energy has to still be 10,000 joules. Now, what is that energy going to be comprised of? Well, I need to know the height. So H in this case is equal to 5 meters, and the gravitational potential energy is going to be M, which is 100, G, which is 10, H, which is 5 meters, and that's going to give me 5,000 joules. So G, P, E, 5,000 joules. I need to know what the velocity is, and that's going to be given to me as 9.48 meters per second. And that's something that I can't calculate, but I'm actually, in your case, you'll be given that. But I can figure out what the kinetic energy is, and that ends up coming out to be 1/2 mv squared, and that ends up giving me, so if I do the math out, that ends up giving me 4,500 joules. So I'm going to take and put that right here, and it's going to be almost as high, but not quite as high. Okay, so if I look here, I've got a gravitational potential energy is 5,000. The kinetic energy is 4,500 or 4,500, which says that the elastic potential energy is going to be equal to the total energy, 10,000 minus 5,000 minus 4,500, and that ends up being 500 joules. So I'll put that in right here, and this is the elastic potential energy. And the important piece here is that the total energy remained the same, but it was now spread among gravitational potential energy, elastic potential energy, and kinetic energy. But they still all add up to 10,000 joules.